Om Swastiastu. So in this video, I will explain about concept and application of set, relation, and function. Before that, I want to introduce myself. My name is Lenny Ariesta Putri, with my last three-digit number is 0x6 from 4A class. So first, set. What is set? A set is a collection of well-defined objects. The objects of a set are taken as distinct only on the ground of simplicity. A set of sets is frequently called a family or collection of sets. For example, suppose we have a family of sets consisting of A1, A2, A3 up to An. That is the family grouping A1, A2, A3 until An and can be denoted as S equals to Ai and I belongs to N and 1 is less than or equal I and I is less than or equal N. Notation: a set is denoted by a capital letter and represented by listing all its elements between curly brackets such as braces. Then type of sets. There are 8 types of sets. First, singleton set is a set containing only one element. For example, A equals to 3 and B equals to friend. Here, A and B are containing only one element, so both are singleton sets. Second, empty or null set. An empty set is a set with no element. It is denoted by A equals to braces. Third, proper set. If A and B are two sets, then A is a proper set of B if A subset B but A is not equals to B. Fourth, power set. The collection of all subsets of a set is the power of that set. If A is the set, then PA is denoted as its power set. Fifth, finite set. A set contains a finite number of elements. For example, A equals to 2, 4, 6, 8, 10, and B equals to A, V, and T. There are 5 objects in set A and 3 elements contained in set B. 6. Infinite set. If the number of elements in a set is infinite, the set is called an infinite set. For example, n equals to set of whole number is 0, 1, 2, 3, 4, and etc. 7. Universal set. Any set which is a superset of all the sets under consideration, and usually it is denoted as S or U. For example, let P is 3, 4, 7 and Q is 1, 2, 3. Then we take S is 1, 2, 3, 4, 7 as a universe set. And the last is equal set. Two sets P and Q are equal if both are a subset of each other. In mathematically, if P subset Q and Q subset P, then P equals to Q. 2. Relation. So what is relation? A relation is a subset of the Cartesian product, or simply a bunch of points or ordered pairs. In other words, the relation between the two sets is defined as the collection of the ordered pair, in which the ordered pair is formed by the object from its set. Example: braces -2, 1, 4, 3, 7, -3, usually written in set notation formed with curly braces. Type of relation. There are 7 types of relation. First, empty relations is one in which there is no relation between any elements of a set. Second, universal relation is a type of relation in which every element of a set is related to each other. Third, identity relation. In an identity relation, every element of a set relates to itself only. For example, in a set A is A, A, B, B, C, C. Fourth, inverse relation is seen when a set has elements which are inverse pair of another set. Fifth, reflexive relation. In a reflexive relation, every element maps to itself. Sixth, symmetric relation. In a symmetric relation, if A equals to B is true, then B equals to A is also true. In other words, a relation R is symmetric only if B, A elements R is true when A, B elements are. And the last is transitive relation. For a transitive relation, if x, y elements are, then x, z elements are. 3. Function. What is function? A function is simply used to represent the dependence of one quantity on the other and is easily defined with the help of the concept of mapping. In simple words, a function is a relation which derives one output for its input, and also a function is defined as a relation in which every preimage in the preimage set must have one and only one image in the image set. The relation which is function. A function is a relationship from set A to set B if every member of set A is paired with exactly one member of set B. All members of set A or the region of origin are called domains, while all members of set B are called codomains. You can see in the slide there is a function and not a function. And then surjective function. The surjective function, also known as onto, is a function with the characteristic that codomains members may have more than one pairs, but there may not be unpaired codomain members. You can see in the slide there's a set A and set B. It is a surjective function. And injective function. An injective function is a function whose codomain member is only paired once with a domain members. You can see in the slide, in the right side is injective function and in the left side is not injective function. And then bijective function. The bijective function or one-to-one correspondence is both injective and surjective. In other words, each member of the codomain in the bijective function has exactly one preimage in the domain. You can see in the slide there is a bijective function, and in the below side below section you can see there is not a bijective function. And then identity function. A function fx is called an identity function if every member of the domain is mapped to itself, or in the other words, fx equals to x for all x in the domain. Constant function. A function is said to be a constant function if it maps every element in the domain to the same constant value. In other words, for a function f a then b, fx equals to c for all x in the domain A, where c is a fixed constant. You can see there is an example in the slide that fr then r given by fx equals to 3 with a domains of -3 is less than or equal x and x less than 2. The graph of this function will be a horizontal line passing through the point 2, 3 and extending in the family to the right. Since the value of fx is always 3 for any value of x in the domain. Note that the domain of this function is restricted to the interval brackets -3, 2. So that's all material that I can explain. Thank you.